Hey guys, today we're going to take a look at some measures of central tendency. So, in other words, we're looking for I'll just read the definition here, where these are different methods of determining the values around which the data clusters. So we're basically looking at different ways of finding sort of the middle of the data. And I mean different things by that depending which type of central tendency we're talking, or different measures we're talking about. So, the first one is the mean. Now, and these are all like you've learned about all of these way back in elementary school, but we're going to look at these in different ways and kind of do more intense things with them, or more challenging, in-depth things. So first of all, the mean is the sum of the values divided by the number of values. All right. So one thing that's new here, it's important we differentiate between the population mean and the sample mean. So you have to decide, is this the mean of the entire population, or are we just looking at a sample here? So what you're going to do is you're going to use the letter mu, which you may have seen in science class. That's not a very good job of drawing it. So let me try again and make it look nice. It should look like a U with like a line there, or like I think of it as a fancy M, but it's pronounced mu or mu. And this represents the population mean. So that's what you're going to use if you're finding the mean of the entire population. If it's just a sample, you're going to do X with a bar over it. And the name of this is very clever. It's called X bar, because there's an X and a bar. So there we go. So the formulas for these are the exact same. It's just that you're using all of the data, or some of the data. And so we do our fancy sigma notation here, and we'll say we're going to add up every single piece of data. That's what that means. We add up every single piece of data, and then we divide by capital N. And it's important. It's capital N for a population mean, because that is the number of items in the population. Population. All right. Next we have X bar. So this is the sample mean. Again, it's exactly the same thing. You add up all of your data. It's just that you're only looking at the number of pieces of data in this sample. And so you're actually going to use a lowercase n. And that is just the number of items in the sample. All right. So that's the mean. The next thing is the median, which we hopefully all remember is the middle value when you rank them lowest to highest, or highest to lowest, doesn't make a difference. Okay, it's still the middle. And the mode is the one that occurs most often. All right. Okay, mean, median, and mode. Some distributions have outliers, which are values that are distant from the majority of the data? I just became British for a second. This looks like this grid is this is supposed to be, I didn't even notice this. That's supposed to be down here. I don't know how that happened. But outliers have a greater effect on means than they do on medians. Okay? If you have somebody in your class who isn't showing up to class and is getting a 0%, that's going to have a big impact on your class mean, or your class, which is what we usually talk about, your class average. But the median will basically not even be affected by it. Okay. So two classes that wrote the same physics exam had the following results. We're going to determine the mean, median, and mode for each class. So we're going to start with the mode and the median, because they're way easier. So let's go mode. All right. So mode is the one that occurs the most, and if we go through, we have 71 more than anything else. Median, very slightly more difficult. Okay. We're just going to count through and find the middle data. So you can just go, I mean, this is pretty straightforward, but you can just go 1, 2, here, let me use a bigger, 1, 2, I'm not even counting, you just count in, okay, yada, 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 and you will land on this guy right here, which is also 71. All right, and to do the mean, we will say that we take the sum of every piece of data and divide it by n, So have I left myself enough room here? Not really. I'm going to zoom way in so I have more room. And that is equal to 45 plus 51 plus yada 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 plus 95. We'll start at the bottom, go all the way to the top, just like Drake. And we divide by the number of pieces data, which in this case is 17. And that should give us 72.06. So there's our mean. All right. So let's go look at class B. And for class B, we'll start with the mode. Okay, what's interesting about this one is that we have the same number of people that got 61. There's 2 people got 61, 2 people got 80. And it is okay to have more than one mode. So it's 61 and 80. It is worth mentioning that if you don't have anything repeat, then there is no mode. You do not have to have a mode. All right, median. All right, again, slightly more difficult. So we're going to go and we're going to count in. And what you're going to count in this time is you're going to find that that is the middle right there. That's the middle. And you may notice that we have a 64 and a 69. Those are not the same. So we have to figure out what it is by adding those two numbers together. We say 64 plus 69, and we divide by 2. So that'll give us a median of 66.5. All right. And finally, we'll do the mean. Okay. And the mean, again, it's the sum of all the data divided by the population. Because we're doing the entire class, it does count as a population mean, so we could use mu here. Okay, we'll just do 12 plus 15 plus 92. Okay, and we divide, and this time there are 18 pieces of data, so it will give us 63.83. Okay, and so this kind of gives you an idea of the outliers having a big impact, because you can see this 12 and 15 really kind of brought down our mean. And yeah, that's basically it. I mean, it didn't really have the same effect on the middle number the same way. So anyway, let's jump over to weighted means. Now this is what everybody always wants to know when I hand back a test. They always ask what their mark was on the test, and I say, well, that's complicated. And the reason is to actually accurately calculate it, you do have to find the weighted mean, because we weight the categories at different weights. All right. So the formula for a weighted mean, whoops, let's use a normal color. All right. So that's going to equal, we take the sum, and what you do is you take the weight of whatever the piece of data is, because everything will have a, so for instance, if we were looking at the mark of a test, so we'd take the weight of knowledge and we'd multiply it by the weight, or by the score in knowledge. So you weight it by, or you multiply by your percentage in knowledge. Okay, and you'll do that for all of them, add them all up, you'll do it for all the categories, and then you divide by the sum of all the weights. All right? Okay, so this is where, did I get myself? No, I didn't. Okay, so that is where xi is, so it's what we call the random variable. Random variable. Okay, which is what we're measuring. So what we are measuring. So in the case of marks, we're talking about the marks, okay, the specific, the 4 different marks that you get, okay. The W then is the weight on the variable. On the variable. Okay, all right. So, for instance, Mr. Hall's 10 applied class, Shayla really wants to know, or yeah, she really wants to know what she really got. She got 97 on knowledge, which has a weight of 25, 93 on application, which has a weight of 20, 71 on communication, which has 15, and 38 on thinking, which has a weight of 10%. All right? So what we're going to do is we just go through and we say, So you'll say X bar W. Okay. And yeah, to be honest with you, one like this, you could argue that that's a mu. It's debatable. And if it's debatable, I'll accept either. I don't really care in that case, okay? It's really only when I specifically am asking about that I'll actually care if you use X bar versus mu, okay? So plus 20 times 93 plus 15 times 71 plus 10 times 38. And then we divide the whole thing by 25 plus 20 plus 15 plus 10. All right? And you'll notice that the bottom only adds up to 70, and that's why this works, because it doesn't matter if your percentages don't add up, because sometimes, maybe there is no thinking, or in this case, it's because the 30% is supposed to go to the exam and the culminating and all that. Okay. So anyway, so if you just punch that into a calculator, you should get 81.9. Okay. And so that's what she actually got. That's her real average. Okay. Real average. And if everything was weighted the same, you could just add the scores up and divide by 70, or not even 70. You just divide by 4, I mean, okay? Oh, well, I guess we're supposed to do it, okay. That's the next thing. Okay, so X bar, so in this case, we're just doing what people will typically do, because people will just typically add up those marks. We say 97 plus 93 plus 71 plus 38. And we just divide by 4. And this is what when you just add up the tops and add up the bottoms, this is what you're doing basically. And so that'll get you 74.8. And you can see that that's no good. No good. Okay? That's no good. Okay, just by using this different type of average, I mean, that made a difference of over 5%. Okay? So make sure you're doing weighted means when you're calculating your test scores, okay? It'll work in all your classes. All your classes it'll work. All right? Okay. So the next thing we're going to do is calculating a frequency mean, all right? So when you tally up, because sometimes we can even jump ahead and look at this this question here. When we talk about time spending watching TV, probably no two people are actually watching the exact same amount of time. So we group people into these intervals. We say between 0 and 1, 1, 2, yada, yada, yada. Okay? So what you're going to do to find this is you're going to add up. You're going to take the frequency, and then you're going to multiply by the midpoint of the interval. And then you're going to divide that by the sum of all the frequencies. Okay? So you take the frequency, multiply it by the midpoint, and then just divide it by all the frequencies. Okay? If you're doing so I'm actually going to change what this says a little bit. So this is this one's intervals, and then this one we'll call non-intervals. Okay, so this one is where it is discrete data, and so I'm just going to change that so that it's still a frequency mean. We'll still call it a frequency mean, but we'll call it mu still, because it's still the population. And the only thing you'll do here differently, so this is actually the easier one. You take the frequency, you multiply by the actual piece of data, because everybody in that group has the exact same piece of data, and we divide by the sum of the frequencies again. Okay, so that sounds more complicated than it really is, and we're just going to walk you through an example here. So, group of children, we asked them how much time did they spend watching TV, and we record it in this data. Okay, so one kid said between 0 and 1, 4 kids say between 1 and 2. So you can see how we're using intervals here, and we're doing that because it's not discrete data. Okay, so by making intervals, it's a little bit like when we talked about the histograms. It's just a way of being able to work with that. Okay, all right. So first of all, we're going to find the mode. Okay, the mode, which the mode of course is just the most frequent. Well, when you're looking for the mode on this one, that's the easy one to do because it's just 7. It's just that one because it's got the most. So the mode is 2 to 3, and that's all there is to it. Okay? The one that were the most people in that interval, that's the mode. All right? So let's see, let's just zoom out here. Yeah, okay. So we're going to do the frequency mean here, which you don't actually have to call the frequency mean. It is a frequency mean. You can still just call it the mean. But what you're going to do, because we got these intervals, we're going to find the midpoints for all of them. So it's just going to be 0.5, 1.5, all the way up. It's just the 0.5s. Added an extra dot in there. Get rid of that. That didn't help. Oh, geez, did I erase everything? Yes, I did. Okay, well, let's try. Oh, we're good. Okay, it's fine. I know how to use a computer. We're cool. All right, so all we're going to do here is we're just going to go through. We say, well, there was one kid that was in that 0 to 1, which we're calling 0.5 as the midpoint. Plus, then we had 4 times 1.5. Plus, we had 7 times 2.5. Plus 3 times 3.5. Plus 2 times 4.5. Plus 1 times 5.5. All right. And we just divide by the sum of the frequencies, which is just the 1 plus 4 plus 7 plus 3 plus 2, which should just add up to however many people there were. Okay? You throw that in your calculator, and you should get 2.72. All right? And that's it. So this is considered an estimate. All right? The reason this is only considered an estimate, of course, is because we're treating it like if you said between 0 and 1, we're saying, well, then you watched 0.5. And that's not necessarily true. It could be that you watched 0.0001, right? And if everybody in each group was, instead of between 1 and 2, or well, even if we look at the people from 2 to 3, if all 7 of those people, it was just barely over 2, then this isn't really all that accurate, right? So that's why it's only an estimate, okay? All right, and that's it. So until next time, go Sabres.